Have you ever wondered how an email you send from one country can reach another country across the ocean in just a few seconds? The answer is hidden deep beneath the waves. Lying on the ocean floor are special, super long wires called subsea cables. These cables are like the internet's secret highways. They stretch for thousands of miles, connecting continents and allowing us to share information, watch videos, and talk to friends all over the world. These amazing cables are the backbone of our global communication network, carrying almost all of our international data. These aren't just ordinary electrical wires. Subsea cables are incredibly complex and strong, designed to survive the harsh environment of the deep sea. They have many layers of protection, including steel armor and plastic coatings, to keep them safe from things like ship anchors, fishing nets, and even curious sharks. Inside all that protection are the most important parts: tiny strands of pure glass called optical fibers. These fibers are incredibly thin, about the same thickness as a human hair. It's through these tiny glass threads that information travels at nearly the speed of light. For many years, we only thought of these cables as tools for sending our data. They were built and laid on the seafloor with one job in mind: to connect our digital world. Scientists, however, saw another amazing possibility. They realized that these cables, which already crisscross the vast and mysterious ocean floor, could be used for something more. They could become a giant network of sensors, helping us explore and understand the parts of our planet that are the hardest to reach. This idea opened up a whole new world of scientific discovery. Using these existing cables for science is a brilliant idea because the deep ocean is a very difficult place to study. Sending submarines or robotic vehicles is expensive and can only explore a small area at a time. Placing special scientific sensors on the ocean floor is also very costly and hard to maintain. But the subsea cables are already there, stretching across huge distances. By finding a way to use them, scientists could get a continuous stream of information from the deep sea without having to build a whole new network from scratch, saving time and resources. So, how can a cable that carries internet data also listen to the ocean? It all comes down to the amazing science of light. Inside the optical fibers, information is sent as tiny pulses of laser light. Imagine sending a message using a flashlight, turning it on and off in a special code. That's similar to how these cables work, but on a much faster and more complex scale. These light pulses travel down the glass fibers, bouncing off the inner walls of the fiber in a process called total internal reflection. This allows the light to travel for very long distances with very little loss of signal. Scientists use a special technique to turn these cables into listening devices. They send a steady stream of laser light pulses through one of the spare optical fibers inside the cable. As this light travels, it behaves in a very predictable way. However, if the cable is disturbed in any way, if it gets stretched, squeezed, or even just wiggles a tiny bit, it affects the light traveling inside. The glass fiber is so sensitive that even the smallest vibration can cause a change in the light pulse. This is the key to hearing what is happening in the ocean around the cable. The scientific method for this is called distributed acoustic sensing, or DAS for short. Here's how it works in a simple way. As the pulses of light travel down the fiber, tiny, natural imperfections in the glass scatter a very small amount of that light back towards the source, like an echo. Scientists have a special instrument at the end of the cable that listens for these light echoes. When the cable is perfectly still, these echoes are very regular and predictable. But when something causes the cable to vibrate, the echoes change. By carefully analyzing these returning light echoes, scientists can pinpoint exactly where along the cable the disturbance happened and how strong it was. The timing of the echo tells them the location, and the nature of the change in the echo tells them about the vibration. It's like having thousands of virtual microphones all along the length of the cable. This turns a simple communication line into a powerful scientific instrument that can detect even the faintest movements and sounds from miles away, all without disturbing the ocean environment. What kinds of secrets can the ocean tell us through these cables? We can learn about some of the most powerful forces on our planet. For example, scientists can use the cables to detect underwater earthquakes. When the seafloor shakes during a quake, it vibrates the cable lying on it. The DAS technology instantly picks up these vibrations, allowing scientists to detect earthquakes, especially smaller ones in remote areas that traditional sensors might miss. This can help us understand tectonic plate movements better and could even improve tsunami warning systems in the future. The cables can also hear the sounds of life in the deep. Imagine being able to track the journey of a giant whale as it swims across the ocean. The low-frequency songs and calls of large whales like fin whales or blue whales create pressure waves in the water that gently move the subsea cable. Scientists can analyze these signals to learn about whale migration patterns, their population sizes, and how they communicate. This is a non-invasive way to study these magnificent creatures, helping us protect them without ever getting in their way. Beyond big events, this technology can reveal the constant motion of the ocean itself. Scientists can listen to the rumble of underwater storms and track how storm waves interact with the seafloor. They can also detect underwater landslides, which can be a danger to coastal communities. Even the steady flow of deep ocean currents can cause subtle changes in the cable, giving us new data about how water circulates around the globe. This information is vital for understanding our planet's climate and how it is changing over time. This method gives us a continuous, real-time look at the deep sea. Traditional ocean research often involves collecting data in one spot for a limited time. But with subsea cables, we can listen 24 hours a day, 7 days a week, across an entire ocean basin. This provides a much bigger and more complete picture of the processes happening deep beneath the surface. It's like we have finally put a stethoscope to the chest of the ocean, allowing us to hear its heartbeat and its whispers for the very first time. The potential for this incredible technology is just beginning to unfold, and its future is incredibly bright. As we continue to refine the science of listening with light, we will be able to learn even more about our planet's last true frontier, the deep ocean. Using the existing network of over 1 million kilometers of subsea cables as a global scientific sensor is a game-changer. It represents a new era of oceanography where we can monitor vast areas of the seafloor continuously and affordably. This will undoubtedly lead to discoveries we can't even imagine yet. One of the most important future applications is in improving our safety. By providing better and faster detection of offshore earthquakes and the tsunamis they can trigger, this technology could save lives. Early warning systems could give coastal communities more time to prepare and evacuate. Similarly, monitoring underwater volcanic activity or landslides near critical infrastructure can help us prevent disasters. We are transforming our global communication network into a planetary defense system, using light to keep us safe from natural hazards originating in the sea. This technology also holds immense promise for environmental conservation. By tracking marine mammals and understanding how human noise from shipping affects them, we can create smarter policies to protect them. We can also monitor changes in ocean temperature and currents with greater detail, which is crucial for understanding the impacts of climate change. This will provide scientists and policymakers with the hard data they need to make informed decisions about protecting our precious marine ecosystems for generations to come. Ultimately, turning our subsea cables into an ocean-observing network is a perfect example of human ingenuity. It's about looking at something we already have and seeing a new, world-changing purpose for it. It connects the world of big data and global communication with the world of deep-sea exploration and planetary science. By simply listening to the light traveling beneath the waves, we are unlocking the ocean's deepest secrets and building a safer, more knowledgeable, and more connected future for everyone.